Okay, so hi everyone, and thanks for coming here. So in this talk today, I would like to discuss optics. Optics is a subject that is very popular among conference speakers and bloggers, but it's something that we rarely see in real-world applications. Why is that? So that's something that I will try to answer in this presentation, but I also would like to discuss a couple of ideas that I have to make optics more popular. So just a few words about myself. My name is Julien Truffaut. I'm a Scala backend engineer for about 8 years, and I also teach functional programming in Scala. I created a course called Foundations of Functional Programming that so far I run it as an on-site training course, but I'm in the process of converting it online, and I hope to release it in September. So you will probably hear about it very soon. I'm also one of the maintainers of Monocle, a library that I created around 6 years ago that implements optics in Scala. Okay, so for today, what is the agenda for today? First of all, I would like to talk about what kind of problems optics are supposed to solve. Why do we want to learn this topic? Then I will do a quick introduction, but really present optics, not the implementation, but more like what do you need to know as a new user of the library? What is a core concept you need to know? Then I will present 3 examples that I think that are really realistic, things that I'm pretty sure you have in your own application, and we'll compare how the standard library in Scala and Monocle solve this problem. And I will use it as a way to describe the current issues we have with Monocle. Then I will present you Monocle 3, which is the new major version of Monocle that will be available for Dotty or Scala 3 only, and hopefully it will solve most of this problem. Okay, does it make sense? Okay, so why optics? What problems do they solve? I don't know you, but the way I learned programming, every single data structure had variables inside. So in Scala, we can have the same thing. You can create a couple of case classes where we use the var keywords for every single field. So here I have a user, and a user has an address. And it's very convenient because once you created a user, you can access the street number by just saying julian.address.streetNumber. This is the same if it's immutable or mutable. But the nice thing with variables is that we can as easily update our street number. You say julian.address.streetNumber equals 16, and this way we will mutate the current user and set in street number. So I think this syntax is great. It's very simple, very understandable, probably also because we learn it this way. But I think it's very concise, it's very good. So why are we trying to work on this? Why are we trying to improve it if it's already very good? Well, the problem we have is that in functional programming, we try not to use mutable data structures. We try to use immutable ones. I think nowadays it's fairly well understood why. Even many programming languages have immutable data structures. We have DevOps with Dockers, Kafka, this sort of things. I think immutability, I think most people understand it nowadays. But still, it's worth to go through a couple of advantages of it. First of all, it's easy to share data. Because if you have a mutable state and you share it, then you let someone else potentially mutate your state. And generally, it's not something that you want. Even with actors, for example, you have a mutable state, but when you send messages, it's only immutable messages. You also get some free features like versioning or rollback, because you never destroy or change something. You only create something new. So you can always come back in time if you want. That's very convenient. This same feature is also very useful for testing, because in testing, you kind of want to start with an object, do some kind of transformations, and then at the end, you kind of want to compare the new result with the original data you had. So this is convenient because you always have access to the previous version. And I think the most important point for immutable data structures is concurrency. And recently, I was listening to this podcast called Co-Recursive. It's really a great podcast. It's available on the web, but also on iTunes. And the host, Adam, on the left, interviews various thought leaders in the industry. And in this particular one, he interviewed Jim Blandy, who is the author of Programming with Rust. From what I heard, this book is kind of the Bible in Rust. And I really like what Jim was saying. He said that we had an engineer at Mozilla who decided to use a thread sanitizer tool to look for data races. And this was inside of the C++ code base. And he said that he found that in every case where Firefox used threads, they had data races. Not most, every single case. And this I found extremely interesting because, Firefox is a software that is, you can imagine that at Mozilla, they have pretty good developers. And it's a software that is used by millions of people, so it's very well tested. On top of that, they have tons of hackers who try to break Firefox every day. So you could imagine that Firefox is quite a reliable application. And yet, even then, they realized that every case they were using concurrent threads and mutable data structures, they were screwing up. And I think this is something that we need to understand. We tend to like to say, oh, I'm clever enough, I can do it. I can deal with mutability and concurrent thread. I can do it because there are some tools for doing this. The answer is that no, we can't. There are proofs that we can't do it right. We need to either have, like in Rust, to have a language that verifies for us that we do it correctly, or we need to use immutable data structures. To do it otherwise is just like a mistake. Okay, so now if we accept that we use immutable data structures, the question is, how can we change it? Because, at the end of the day, our application is not static, so we need to change. But how can you change something that by definition cannot change? So I have a story for you. You may have heard it. And it's about how a functional programmer changes a light bulb. So imagine, you're a clever functional programmer and you live in an immutable world. And you're at your desk and the light bulb at your desk is broken. It doesn't work. So you want to change it. So in a normal world, you will just unscrew it and put a new one, right? But you can't because you're in an immutable world. Like unscrewing and putting a new one will be a mutation. So how can you do this? Well, you're a clever programmer. So you say, okay, I have an idea. Let's create a new planet from scratch. Okay, so we create a new planet and we're going to copy over every single ocean, every single mountains, continent, forest, everything. Then we copy every single city, building. In our building, we copy every single room, every single piece of furniture, the lamp, but we don't copy the lamp, the light bulb. This is the only thing we don't copy in the new world. And this is where we put a new one. Easy peasy, we got a new light bulb, we fix the light, the light. So I would like to thank Imperpix for this series of diagrams. He's very an awesome chap in the functional programming communities and really nice diagrams. But the first time I heard this kind of stories, I thought this is probably the dumbest idea after the white space language, where you only program with white spaces and tabs. Why on earth would you want to to create everything over to just change a tiny thing? It turns out that it's not that stupid because, everything that don't change, like for example, I live in London, I can very well reuse Africa. I don't live there. So I don't need to recreate a new one. I can just reuse everything as I didn't change. And turn out that actually, because we cannot have a hierarchical data structures, you only need to change a couple of nodes in order to create a new planet, even so it's a massive object. So it's not the most efficient way to do it, that's for sure. But in reality, it's not that bad. Okay. So now this leads to the question, how can we copy something in Scala? Because, okay, so we know that for mutating something in an immutable world, you need to copy things over. So how can we do it in Scala? And this is where I have 3 examples for you. So first of all, the most simple case. Let's go back to our example with a user and an address. But this time, every single field is immutable. So now that we have a user, how can we change his street number using the standard library in Scala? How can we copy case classes? Well, it turns out that Scala makes it easy for us. We can just use a copy method. So we can say julian.copy. This will create a new user, and I can just specify what are the fields that I want to change. So here I said I only want to change the address, but potentially I could change several things at the same time. And how do I want to change the address? Well, I want to take the current address and I want to copy it and change the street number. So it's a pretty nice syntax. It's not the most concise, it's not as concise as we had with mutable data structures, but it's not that bad. And it's scales relatively well. You know, if you have your data structure 3 or 4 level deep, it's still like manageable. It's not beautiful, but it's manageable. And most of the time, we don't have data structures more than 2 or 3 level deep, so it's really fine. The thing is that in general, we don't have data that simple. Quite often, we have things like enumerations. So an enumeration in Scala use a CL trait. So a CL trait, you say, okay, this is a trait, and it has only 2 implementations. So a payment method says that there is only 2 payment methods in my application. You can have a PayPal account, which is basically an email, or you can have a debit card, which is a card number, an expiration date, and a security code. So you only have 2 possibilities. And we're going to extend our user to add a payment method to it. So now a user has a name, an address, and a payment method. So you cannot have both a debit card or a PayPal, you have one or the other. And let's create a user, Julien, who has a debit card, and Anna, who has a PayPal account. Now, I know you guys, no need to screenshot this page. This is not my debit card. And if this debit card works, it's complete luck. So now the question is, now that we have a user, how can we change the expiry date? So let's try to use the same techniques that we did before. Let's write a function that takes a user and a new expiry date. And let's copy the user, okay? And let's change the payment method by copying it over and changing the expiry date. Same thing. Well, the problem here is that it doesn't work because payment method is a CL trait. CL trait don't have copy method. It's only case classes that get it from the compiler. CL trait don't have it. And it makes sense because, you know, if my payment method is a PayPal account, I can't change the expiration date inside. So the general question is, how can you copy enumerations? Well, with enumerations, the answer is almost the same. You need to pattern match. So let's write our copy method, the same at the beginning. And then within the copy method, we pattern match on the payment method. If the payment method is a debit card, then that's easy. We can just copy it over and change the expiration date. Fine. The real question is, what do we do if it's a PayPal account? Actually, we don't have much choice here because we are within a copy method. So we have to return a payment method here. So either we throw an exception, but we don't really like to do that in FP, or we have to return the same object unchanged. So if you want update expiry, either change the debit card if your user has a debit card, but if it has a PayPal account, then it does nothing. It's a no operation. If we wanted to return something a bit more useful like an option or an either, we would have to move this pattern match outside of the copy method, which is a bit annoying because we would like to have kind of a consistent way to implement these kind of functions. But again, it's not the end of the world. Okay, now imagine that your boss come to you and say, okay, actually, we changed our mind and we want that our users have several payment methods. And so they can have several debit cards, several PayPal accounts, and we want them to allow them to put like a name for each payment method. So you're like, okay, boss, no problem. Let's, oh, sorry, I forgot, but this is how it works. You say, okay, no problem. Let's change our user, and this time it's gonna be a map string to payment methods. And for example, Julien is a user, has a personal payment method that is a PayPal account and a business debit card. Fine. And now same question again. How can we change the expiry date for one of these payment methods? Okay, let's go back to the drawing board. Let's go back to our previous implementation. This time we need to look up inside of the map. So we say, okay, we have a map. We look it up by payment name. But now we have 3 cases, not 2. We have the case where it's none, where this payment method doesn't exist. We have the case where it's a PayPal account, and we have the case where it's a debit card. In the first 2 cases, same as before, we can't do anything about it. You know, we have to return a payment methods. So we can't create a debit card out of nowhere. So we kind of have to return the payment methods and change. The only thing we can do is for a debit card, we can copy it over, and then we need to insert it inside of the map, upsert it using updated. So this starts to be very boilerplatey. It's also very annoying that we kind of, these 2 cases are, you know, we can't distinguish between these 2 kind of errors. But really the most annoying thing about this function is that it's still, manageable to write, but it's really not fun. It's not the kind of function, when you're done writing it, you stand up and you go to high five your colleagues, say, yeah, I did it. No, it's very boring. It's really not nice to write. And, it's not easy when you review the code to exactly see what's going on. The intent of this function is quite buried inside of the code. So let's try to see how optics can help. So what's an optic? An optic is basically a trait, so an interface, that has two type parameters, from and to. If you think about it, from is kind of a big type like our user, and to is like a tiny thing inside of from. So imagine from is user and to is the expiration date we want to change. And an optic has three methods. Get, it says that, if you give me a user, I will give you back its expiration date. Replace, that, if you give me a user and a new expiration date, I give you a new user with this expiration date replaced. And modify, which is kind of a convenient method where, sometimes you kind of just want to change the expiration date, say, okay, plus 1 year or plus 2 years, something like this. So it's kind of a combination of get and replace, which is quite useful. It turns out that in reality, there is not only one optic, but several optics. And they have weird names, like things like lens, optional, traversal, prism, ISO. And the names are not really helpful because, some of them follow this optics analogy like lens and prism, but like an optional and a traversal, it's not really an optic. So names are weird. But to be honest, we don't really need to understand why the distinction between these optics. The only thing we need to know is that, between different kind of from and to, there is different relationship, and each lens encode one particular kind of relationship. And generally speaking, the main difference is around this get method. Because if you think about it, if you have a user, you're always able to access his name. So it's always one value here. But if we want to access the expiration date, it's more like an option because there might not be an expiration date. But you could imagine also we could generalize it to be a list where you are able to target several items at the same time. So this is the main difference between optics. But as I said, it's not. I think the most important part is to understand that an optic has two type parameters and these three methods. Now, if an optic was only this, it would be fairly useless. The critical part of an optic is the optics composition, which behave exactly like a function composition, which means that, if you have an optics from to and an optics from to next, you're able to use and then to basically drill down into your data structure and like compose these two optics. Let me show you with a real example. So here I drew the representation of our user. So a user has three fields: a name, an address, and payment methods. Payment methods is a map, so it has several keys. So for example, personal and business. So first of all, from our user, we use a payment methods optic to go through, to zoom into this field. Then we use the index optic here to select this branch to go into the personal key in the map. Once we have a payment method, it can be a debit card or a PayPal account. So we use a debit card optic to select to say that we want our payment method to be a debit card. And finally, we use the expiration date optic to say we want to go into the expiration date field. And as you can see, I drew these two arrows with dot because potentially it can fail. There might not be a personal account, a personal debit card, or the payment method that we have may not be a debit card. And if we compare, so the question is now, I think it's quite readable, this, it's quite nice. I like that, for each optic corresponds to one arrow in this diagram. The question is, why optics are not more popular in Scala? It sounds quite a good idea. I think there are several reasons why. I think one of them is, people who talk about optics, we tend to focus too much into the implementations of optics. Because to be honest, it's probably the most beautiful functional programming implementation that I've seen. And I think many people, when they discover it, they just want to talk about it because it's such a revelation. But as an end user, you don't really care, to be honest. As you've seen, the interface of an optic is fairly boring. It's more the implementation that is interesting. So this is one reason. And there are others that I will discuss next. So let's compare vanilla Scala, so the standard library in Scala, and optics. So we can see that the update expiry implemented in two ways. I think the optics one is a winner. It's slightly more concise, but most of all, it's clearly the intent is more clear. Especially, once you know a bit about what's an optic, you can really understand that each optic allows you to drill down one level in your data structure. While here, it's not really clear what we're doing. And the nice thing is that once you generated your optic, you can get, replace, or modify. You can do everything you want with it. It's fairly flexible. So if it's so good, why don't we use it? So there are a couple of reasons. One of them is that I actually lied to you in Monocle. So now I'm going to talk about Monocle. In the current version of Monocle, we don't have a single compose method. So we don't have and then. We actually have several methods like compose optional that takes an optional and gives you a new optic. Compose prism that takes a prism, compose lens that takes a lens. So we have one compose method for each type of optic. And here it's annoying on several accounts. First of all, it's not concise. Like it's the signal to noise ratio of this implementation is very bad. Most of the code is for this composition, which hide what we're doing. So this is annoying. But I think the worst is for newcomers in the library. If you don't know anything about optics, you don't know what's an optional, a prism, or a lens, and you probably don't want to know right now. You just want to do your stuff. So we should hide this sort of thing. It's kind of an accidental complexity. We shouldn't expose this sort of things. So why did we do this? We could have very well used overloaded methods. So we may need several compose methods, but we could have given them the same name. We can do that in OOP. Well, this would have been great, and it's partially possible. The main issue is that it actually breaks type inference in some cases. And it's particular for the function like index, because if you think about it, index is fairly generic. It lets you go into a particular key in a data structure, but this data structure can be a map, a list, or something else. So when we call index, we have to figure out what is the exact data structure we want. So we need some kind of type inference. But turns out that Scala 2 has a fundamental limitation where when you have overloaded methods, the type inference is not as good as for methods who are not overloaded. And it makes kind of sense because, if in order to figure out which overload do you want to use, you need to know the type of the arguments. But in order to know the type of the arguments, you need to know which overload method you need to call. So it's kind of a chicken and egg problem. So it makes sense, but it's annoying. So if you want to read a bit more about this, there is this issue in Monocle that describe it more. And also, I really like this blog post from Michael Pilquist, who explained how FS2, a streaming library in Scala, how the design of the library is entirely driven by type inference. And this is something as an end user we don't really realize. Because Scala is a very powerful language. We can do tons of stuff, but actually there is only a relatively small subset that we can do where we get a nice type inference. So in Monocle, we made the design decision that we will offer non-overloaded compose method in order to have nice type inference. So it's a trade-off. I'm not sure it was a great decision, but this was a decision we made. Now, the great thing is in Dotty, in Scala 3, type inference is miles ahead of Scala 2. And this is kind of the silent improvement that, we don't really talk about this in Dotty, but it's really, really good. And I think it's the most important part of Dotty. So in Dotty, we should be able to have a single compose method. So this will simplify drastically the usage of Monocle. And also what's going to be great is that it will help all the other libraries that exist in the ecosystem. So you may not notice it in your applications, the change in the type inference, but you will notice that libraries are going to be much more powerful in Dotty. And I'm really looking forward for this. Also, I have a question for you. So one thing where we are not sure yet is should we should we make the composition an infix operator? So this like triple chevrons. The benefit of this is that, it kind of really breaks down the optics from the composition, because the composition is just like, we want to, put one after the other. It's not really the important part. So I quite like the fact that it separates the optics from the composition, and it makes it slightly more concise, but I don't think it really matters. But at the same time, I think many people don't really like operators. So I'm not entirely sure what should we do. I think probably and then will be better. And I think we should only offer one of them because, we already have too many decisions to make every day, so library shouldn't give you like, cosmetic changes to decide. Like, I don't want people arguing endlessly in PR, should you use triple chevron or and then. We need to offer one or the other, but I'm not entirely sure which one is best. So please head over to Slack or Twitter and let me know your opinion. Will be useful. Okay, so this is one of the great things that's going to happen in Monocle 3. Another one much more important, and I think it's going to be the biggest change that's going to happen in Monocle, is regard optics creation. So this is something that quite often we don't really talk too much when we discuss optics. So one of the goals of optics is to kind of reduce the boilerplate. But these optics that we use in this function, we have to create them at some point, right? They don't come out of thin air. So we have to define them somewhere. And generally the optics definition is not a one line. So actually we don't really reduce the boilerplate. We just create more boilerplate, but somewhere else. So that's really annoying. One thing you could say is that index probably is generic enough that it will be offered by the library. But payment methods, debit card, and expiration date, you have to create them yourself because it's about data types that comes from your domain. So the library cannot offer them for you. So one thing we did in Monocle 2 is to offer macros. So we have this genLens macro and genPrism macros that allows you to create certain optics quite concisely. Now, still the problem with that is that we're still leaking the kind of optics you're creating. And as a beginner, you don't really know what you want. You kind of just say, oh, please create an optics for that, particular path within my data structure. I'll figure it out, We also offer macro annotations for lenses. So you're able to say add lenses to your case class, and this generates for free, immediately, these lenses inside of the companion object, which is great in terms of to cut the boilerplate. But the problem is that it requires some specific support for IDE. So we did it for IntelliJ. But the main issue is that macros annotation don't exist in Scala 3. So it's kind of a dead end, no points to waste more time into that. Another approach we could do is to do a bit like people are doing in Kotlin, is to have a compiler plugin that will generate optics for everything in your code base. So that might be an approach that we consider. But actually recently Julien was experimenting with Monocle 3 and created an awesome macro that's called focus. And focus is basically the dream macro, because what it does is that you just say, what is the case class you want to start? What is the class you want to start to create an optics for? And then you just have a lambda to describe where do you want to go. So you say, I want to go into payment methods. Then I want to go to this index. Then I want to see it as a debit card and expiration date. And this macro is going to generate the right optic for you for free. So you don't have to know what is it. It will generate the right thing just for what you want. So this is not going to implement 100% of the optics, but if we can have 90% or 99% of the optics out of the box like this, this is a gigantic win. And also we have, because this is a lambda, we have straight away support from the IDE. So I really am very impressed by the work of Julien. And we can even have an infix syntax because, this is quite nice when here we create an optics and then we use it. This is useful when you want to create an optics and use it many times. But quite often we just want an optics I use it once and throw it away. So we may want to have an infix syntax for this to say, okay, because there are two different usages. We'll see. Let me know what you think about it. But anyway, I really think that this focus macro is going to be amazing. Last problem for today. I want to talk about lawfulness. So this, I hate this name. I don't know if you ever try to explain it to someone or being explained what is being lawful or not lawful to someone, but it's bad. You know, like people laugh at you, say, what do you mean it's not lawful? I mean, will you have the lambda police that come to your desk and, you know, beat the shit out of you because you did something unlawful or put you in jail? No. What people mean by lawfulness is just, you know, an object is a trait, an interface, and it has a couple of methods, and we expect some behaviors. There is a contract that relate these different functions, and that's it. You know, a law is just a test or a contract. That's just what it means. So an object has several tests, several contracts, and they generally make sense. You know, they're generally stuff that you would have come up with if you just spend a couple of minutes thinking about it. Let me present a couple of them. So we have this get after replace property. It says, you know, imagine you have an object that's focused from a user to its name. Let's generate a random user, a random name. If you change, if you call replace to change the name inside of the user, so you get a new user, and then you call get on this new user, you expect to get the name that you just set, right? It's like if you think about an object like a getter and setter, it just means that, you know, the setter actually works, does its job. Nothing really fancy about it. Another interesting property is called the modify fusion. So this one is a bit more complex, where you say, okay, we still have the same object, but now this time we have two update functions. So an update function from string to string, and another for string to string. And what we're saying is, if you call these two update function one after the other, so you say modify update one, you get a new user, and then you modify the new user using update two, so you have two steps, then you can basically squeeze these two steps into one by just calling modify once with these two update functions. It kind of makes sense, right? You can, and it's nice because it means that we can potentially, if we could parse our program, we could make it kind of more efficient. If we notice this pattern, we could try to rewrite it at compile time. It would be nice. So a thing we need to discuss here is that there is a general, like kind of unspoken FP design principle that says, you know, you have two kind of things in libraries. You have constructors, like, you know, if you want to create an object from scratch using like basic operators, and you have combinators. And combinators, they say, like, so yeah, so come back. A constructor, what we say is that if you create an object using constructor, it's up to you, the application developers, to verify that the objects you created is satisfies the contract. And generally what libraries do is that they offer a test suite, such as you can just run the test suite on this particular object. So it's relatively easy, but it's up to you, it's your responsibility to check that this object is correct. Now, the nice thing about FP libraries is that they tell you, once you verify this at the bottom, like for all this basic building block, when you combine them using combinators offered by the library, you don't need to recheck the behavior. We guarantee you that the combining objects will just work. And this is nice because it means that you can safely use the library and combine things together and it will just work. This is a very important property. But at the same time, it has some issues. So here, this is a more complex example. So don't worry if it doesn't make sense just right now. You probably need more than 2 or 3 minutes to understand it. So just come, I will give you the slide afterward and just come back through it. But I'll try to explain it here. So imagine we have this filter optic to our focus macro. So we say, okay, this will behave exactly like filter for a list or something else. So we want to say, I want to focus into a user only if his country is the UK. So, and now Julien lives in the UK, so that's fine. Then I want to go into payment methods. Then I use this asterisk to mean I want to go to all payment methods at once. Then I say I only want to go to the payment methods that are debit cards. And then I want to get their expiration date. So now it means that I get 2 results because this user is in the UK. He has 2 debit cards. So here I get his 2 expiration dates. It's quite nice. And here I use get, but I could have very well used modify or replace. It's just like smaller to put on slides. Now, if we change the country, so if we said this user now lives in France, now the same, and he has exactly the same debit card and payment methods. Now the list is empty because this predicate is not valid anymore. This user doesn't live in the UK. So it's quite a nice optic, this filter. It would be very nice to offer it to our user. But it turns out that in some cases, it breaks the contract that optics offer. So let me walk you through this counter example. It's a bit involved, but let's try to go through it. So now let's say, instead of filtering on the country, we're going to filter on the expiration date. So we say we only want the debit card who has an expiration date after May 2020. And then we focus into the expiration date. So now we only have one result because this one is after May 2020, this one is before. So we only focus into this guy. Perfect, that works. Now imagine now we extract this optic into a value just to make it simpler. And now we call modify on it. So we say, let's take this optic and modify the expiration date by applying -2 years. It works. You know, this expiration date was 2022 March. Now it's 2020 March. Perfect. Exactly what we wanted. But wait a minute. If we try to apply a second modification, so imagine we say now, okay, this is our new user. Let's call +3 months on it. So let's try to modify it again. No, it doesn't work because now this expiration date is before May 2020. So it's not targeted anymore by the optic. So it broke the fusion law, the fusion property, because now if we had implemented it using only one modify and 2 update function, it would have worked. So you see, it's very subtle. It's a very subtle case. I mean, go through this slide again if you want. But basically, if you have a filter optics that has some kind of predicate, and then when you call modify, you change the predicate, then you are breaking the.
Just a moment.
Then you are breaking the optics contract. So it's annoying. So in Monocle 2, what we took this kind of high stance and we said, okay, because there is a tiny chance that you break the properties, you break the contract, we are not going to offer it to you within the library. This was kind of like because we said we want to respect this principle that we only offer safe combinators. Now, I think retrospectively, I think it was a mistake because we need to be able to, filter is very powerful and most of the time it is correct. So we should be a bit like, more lenient and more flexible and say, okay, you have to be careful. Maybe we need to document this corner case. Maybe we need to put some kind of suffix or prefix to the method to say, be careful, use it as your own risk. But we should offer it to your users because it's so useful and it really simplifies your life. Okay, so to summarize what we've seen today, the main difference between Monocle 2 and Monocle 3 is that we're going to drastically reduce boilerplates by first having a single optics composition and have this amazing focus macro from Yelling. We're also going to change our stance with regard to lawfulness and try to be like more lenient and try to have better documentation for this sort of things. And there are like many, many, many more changes that are coming, really awesome. But I think this was the 3 things that I think as a user point of view, you will get the most benefits. But there is tons of work to be done. What I showed you today is like, we did some proof of concept, nothing is really settled down. So we have lots of work to do, not only on Monocle, but in Dotty in general, in Scala 3, it's still like very much work in progress. There is tons of things missing. Like for example, we are trying to have a website for Monocle 3 with type documentation. But at the moment, there is no library in Dotty that offers type-safe documentation. So we are doing like a massive yak shaving thing where we have to kind of fix all the dependencies in order to get things done with Monocle. So we really need your help. This is the current active maintainers of Monocle. So we have Carlos, myself, Yilin, Kenji. But really, if you're interested, please reach out to us. This is not the most beginner-friendly place. We kind of need people who are quite experienced in Scala, who at least really want to spend time, like look into the detail of the compiler in Dotty and stuff like this. But we really need your help because we have tons of work in front of us. But I think it's worth it. And if this is not enough, we have stickers. So we just got a new logo for Monocle. So unfortunately, it's an online conference, so I cannot hand them over to you. But soon, hopefully, once this virus is over, we will. So thank you guys for attending the talk, and please, if you have any questions.